So, is an asteroid headed towards Earth? Well, first of all, there are always asteroids headed towards Earth. What we care about is whether they'll actually hit us or have a near miss. Or I'd rather think of them as near hits. Because if you nearly miss something, to me that means you hit it. Anyhow, there's an asteroid recently discovered, 2024 YR4. That's its designation. And you know that was discovered late in the year 2024 because the letters are late in the alphabet. In fact, I think it actually puts us in December for 2024. The size of the asteroid is still uncertain, but we know it's somewhere between 50 and 100 meters. Some of that uncertainty will be overcome by tasking the James Webb Space Telescope. All of our great telescopes have operation modes where if there's a time-critical thing that's happening in the universe, time on the telescope gets allocated to that event. And this counts as one of those, let's task JWST for helping us figure out exactly how big this asteroid is. The right question to then ask is how much damage would it do? These things are moving very fast. The closing speeds are typically 20, 30, 40, can be as high as 50 kilometers per second. So that's a lot of kinetic energy being brought in. A good rule of thumb here is that the crater would be about 10 to 20 times the size of the asteroid itself. So 10 to 20 times something that's almost 100 meters, we would leave a crater between 1 and 2 kilometers across, all right? A little less than a mile, perhaps. If the asteroid hit a city, leaving a crater nearly a mile across, that would be completely devastating, destroying many buildings, killing many people. Most of Earth is water. Most of what is not water, that is land, is uninhabited. So chances are, if it does hit, it's not going to harm anyone. If it happens out in the middle of nowhere, then it's just an interesting crater. We have one of those in Arizona. It's called Meteor Crater. It's almost a mile across, and you can sink a 60-story building in the center. And when you add it all up using this sort of arcane metric for describing the size of explosions, it would land at about between 8 and 10 megatons. 8 and 10 million tons of TNT, which was this metric invoked during the Cold War and the arms race to describe how much energy was being released with our nuclear weapons. So during that period, we actually detonated bombs of equivalent strength. And in fact, we detonated them in the ocean. And while there were local tsunamis, there wasn't a tsunami that took out the population of the world. So you don't want to be there when it happens, if it happens. I'm just telling you, no, civilization will not come to an end. We will not go extinct. We will not have to worry that we will suffer the same fate as the dinosaurs. So chill on that. The estimate for the chances of it hitting us are down at this moment, between 1 and 2% at the time of this recording. Now, what does that mean? I'll tell you. It means that the orbital trajectory we have for it, when projected forward in time, has an uncertainty cone where the asteroid could end up anywhere in that cone, but more likely in the center of the cone. If it stayed in the center, you can ask, how close to Earth would it come? About the distance from Earth to the moon. Now, let me remind you how far that is. Often when people, if they were told to draw where the moon is from Earth, they might draw something like this. That's how it's shown in textbooks. They show Earth and the moon right there. That is not the distance, okay? If Earth were this size, it would make the moon this size. Its distance would be 10 meters away, 30 feet or more away. That's the distance, well outside of this framing. So if this asteroid, 2024 YR4, stays in the middle of its cone of uncertainty, it will pass Earth at about the Earth-Moon distance. Very safe. It'd be fun to look at with telescopes. It should be detectable. So this chance that the asteroid might hit Earth, we can ask the question differently. Say, if it were to hit Earth, what is the impact corridor that it represents? Since we can't pinpoint it exactly just yet, we can tell you what that part of Earth looks like. So it begins here just south of the equator in the Pacific, crossing the northern portion of South America, crossing the Atlantic Ocean, crossing northern Africa, crossing the Arabian Sea, India, and it ends right here in Southeast Asia. So this uncertainty is the intersection of its path and Earth's rotation. And that's what gives us this very long impact corridor. The press will make clickbait out of this, for sure. But as the orbit gets closer and closer to the 2032 January 22nd passage, that means our measurements will be better and better. So either that risk of hitting Earth goes to 100% or to 0. It will not stay in any number other than those two as our orbital calculations become more and more precise. 0, of course, there's nothing to worry about. 100%, at that level, we will know exactly where on Earth it will hit and when, so that we will be in a position to protect ourselves in advance from whatever damage it would cause. You may remember NASA had a mission to an asteroid to try to deflect its orbit, sort of as a test case in case something might be headed our way. Now that it has done that, knows how to do it, learned that it was successful, it gives us a little more confidence going forward for any subsequent asteroid that's discovered that might actually be headed our way. By the way, any country that has a planetary defense office is perking up right now because of these risks that we now know and can track. In fact, China, just as an example, didn't have a planetary defense office until this asteroid's risk was calculated. We can only be safer in this world if everyone thinks about this problem in a coordinated way, together. And I've been duly notified that 2024 YR4 lands at around a 3 on the Torino risk scale. One of my lifelong friends who I went to graduate school with, his name is Rick Binzel. He invented the Torino hazard scale. Let's see what he has to say about this. You were at a conference in Torino, Italy, where you proposed a way to track how hazardous an asteroid might be. So remind me what you put into it.
Yeah. So first of all, the Torino scale is a 10-point scale from 0 to 10. All right. 0 is really good and 10 is a really bad day for the dinosaurs. And the way you calculate where an object falls on the Torino scale depends on the size or the consequences of what that object would be if it struck the Earth versus the probability, the current best estimate for the probability that it could impact the Earth. And so it's 2 dimensions, consequence and impact probability.
So Rick, do we really have to remember these numbers on the scale?
No, on the Torino scale, we have the 0 to 10 system, but at the lowest level, things are green. You have a green level, which means, oh, this is normal. We're going to find a lot of these. We're currently at that next level up, which is yellow, which just says these merit attention by astronomers. So that's what level 3 is. And if the probability gets worse, we would go to orange, which means there's a possible threat here. And where we want to stay out of is the red zone of 8, 9, and 10, which means we have 100% probability of hitting the Earth. And now it's a matter of what would be the consequences. And those consequences depend on where the object lands.
So Rick, where is 2024 YR4 on the Torino scale?
So 2024 YR4 ranks a 3 on the Torino scale, which means if it were to strike the Earth, it would be a localized event. If it misbehaves, it would go all the way up to 8 on the Torino scale. That would be its maximum. And I think the important thing about a 3 on the Torino scale is we like to emphasize that most likely when we get more data, we'll be able to reduce it to 0. And 3 is also sort of an alert to astronomers to say, let's pay attention to this object. We're not worried about it. No one is panicked about it. But let's get the data and make sure that it's going to miss.
So, as of this moment, that's what's up with that. Until next time, keep looking up.
Every few months, a new headline warns of an asteroid on a collision course with Earth. But how real is the risk? You'll find somewhat reliable sources emphasizing the asteroid's magnitude and which countries might be spared, while other, highly credible sources reassure us there's a 98% chance we'll be fine. Exaggerated language, selective framing, and misleading urgency make it easy for science reporting to veer into sensationalism. The result? More clicks, more panic, and less actual understanding. And that's what makes our partners at Ground News so different. They're an independent app and website founded by a former NASA engineer who brought the same level of precision she needed up in space to how we consume information here on Earth. I can compare coverage from NASA, Nature, and more, with data on each outlet's biases and credibility. I can even see which stories might be missing from my media bubble to ensure I'm forming conclusions based on the full picture. And if I really want a deeper dive in no time at all, their daily briefings analyse the dozens of sources covering this issue for us. Ground News breaks down the facts, what every outlet can agree on, as well as the different narratives shaping the public's perspective. Best of all, Star Talk viewers can get the same top-tier Vantage plan we use for nearly half the price. That's just $5 a month for understanding shaped by clarity and credibility, not clickbait. So head to ground.news/StarTalk or scan the QR code to subscribe today.